Hey guys, so let's have a look at doing some radioactive decay problems. So the half-life of a radioactive substance is the time taken for half of the atoms in a sample to undergo radioactive decay. So in Physics 1.2, the formula that describes radioactive decay is this one here. N equals n0 times by half to the n. Now obviously there's a lot of n's in there, so here's what they all mean. The first n is the amount remaining. The n0 is the initial amount of that radioactive substance. And the last n, the small one, is the number of half-lives. Now in Physics 1.2, this number will always be a whole number, so 0, 1, 2, 3, etc. So with this formula, we can work out how a substance decays. So if we start off with n0 amount of a substance, that's at 0 half-life, so initially. Then after 1 half-life, we'll have half of that amount remaining. That's the definition of a half-life. And after an additional half-life, that amount will be halved again, so we'll have a quarter remaining. And after an additional one, we'll have half again, so we'll have 1/8 remaining. If we were asked, say, how many half-lives does it take for 1/16 of the original amount to be remaining, and we were required to do some working, then we could go, okay, the amount remaining is 1/16 of the original, and then we could use the rest of the formula to try and work it out. So we've got n0 on both sides, so we can cancel that out. Then we've got 1/16 is equal to half to the n. 1/16 we can write as half to the 4, and then since these bases are the same, we can equate the powers. So n is equal to 4. So it would take 4 half-lives for 1/16 of the original amount to be remaining. So keep this formula in mind as you tackle those radioactive decay questions. Thanks for watching.